Good. Good afternoon, everyone. Thanks for joining Inform's NCSU chapter. This is our important session, which is actually a student tutorial session. This program is co-organized with ISC GSA from NC State University. We welcome Rahman Kuramfar, who is one of our PhD students, my colleague, my friend, who is an expert in this area in terms of optimization, and he's very good at programming, optimization problems and solution methods. I have learned personally many programming tricks and how to code for large-scale problems. So in today's presentation, he is going to talk about some of the optimization algorithms which we know theoretically, like column generation, Vender's decomposition, and so on, but it is very difficult to implement using a programming language. I mean, theoretically, we can understand how the math and optimization stuff works, but when it comes to programming, and especially when we are solving a large-scale problem, we go for these algorithms. And we need to have a very good, coding techniques to support this algorithm implementation effectively. So in today's presentation, Rahman is going to give a tutorial. In this tutorial, he is going to show three broader stages. I mean, first he will use the C++ to program a mixed integer linear program, a simple problem to show how this coding works. And then he will give a brief about what is exactly column generation and Vender's decomposition algorithm, why it is important, and how to implement that using C++. So I take this opportunity once again on behalf of Inform's NCSU chapter. We welcome Rahman, and Rahman, it's all yours.
Thank you so much, Sinawasan, for the introduction. Are we going to take a group picture or should I start?
Yes, I think let's have a group picture. I request all the participants to open your camera, open your shutter to have a quick picture, and then we will have the presentation. Zoo, you are taking the picture. You can unmute yourself and you can.
Actually, let's wait for more people to kind of open up.
Oh, okay, okay.
Like only half the people have opened up.
All right. I think none of them are ready to open up. Probably you can take the picture with the existing people. Yeah.
Good.
Done? Okay, please. Rahman, you can start.
Okay. Hi, everybody, and good afternoon if you are in the United States, and good night if you are in Iran or Middle East. And we are going to have a very short tutorial on how to implement all our problems in C++ equipped with Cplex solver. More specifically, in this talk, a mixed integer program, a column generation algorithm, and a Vender's decomposition algorithm will be implemented and or will be explained. So without further ado, let me share my screen. Okay. So C++ Cplex for optimization problems, a short tutorial and implementation. So why we are using C++ for generally many optimization problems? We are using C++ because it is generally very fast, or sometimes at least fast, compared to other interpreter-based languages like Python. Other interpreter-based languages include MATLAB or recently Julia. However, compiler-based languages such as C, C++, Java, and C# tend to be much faster than interpreter-based languages. Many open source solvers are developed in C and C++ equipped with Cplex solver. For example, we can mention this CoinOR website. You can find a lot of good open source solvers here. Like, for example, if I search for C++, you see that a lot of them are written in C++. Or let's search, for example, for Python. No Python in this website. I mean, there might be Python, but not mentioned in this page. But most of them are developed in C++. As well as if you go to the Corel lab, this is a lab mainly in Lehigh University, supported by Lehigh University, and many codes here as well are developed in C++. So that is the reason our focus in this tutorial will be on using C++ for optimization problems. Why we are using Cplex then? There are other options like Groby. Cplex is more popular among OR practitioners. Many people are still using Cplex. It is free for academic use, and it also has good documentations. I mean, in my personal experience says that it doesn't have the best documentation. Groby has the best documentation, but still Cplex has a very good documentation, and we can learn a lot of stuff by looking at the tutorials in Cplex. And also Cplex is more established than similar solvers such as Groby. Groby is another good solver, by the way. So let's start with the first example, transportation problem. Very easy one. We only have two constraints. Our sets are supplier sets. These fonts are different. In this other S is supply array. It is a parameter. D is set of customers or demand points, and the other D is the demand array. And we have cost matrix, cost of sending a unit from supplier S to demand point D. And we also have one decision variable only, which is XSD, and it is amount of shipment from supplier S to demand point D. This is our objective function, CSD, XSD. I mean, over all the transportation happens in between suppliers and demand points. Suppliers cannot produce more than their supply, and demand point should receive at least their demand. I mean, as much as they demanded. And notice that our decision variables are integer here. Okay, so let's start with this problem. I'm going to have a Visual Studio. Before that, let's mention something. Make sure that iLike is installed in your machine. So for my machine, for example, if I simply write Cplex, it will start here. It's showing that it is already installed in my machine. So once I know that it is installed, I'm opening a Visual Studio and going to the Create New Project. Okay, and here I select the C++. You can select other languages. I mean, Visual Studio supports other languages, but we are going to have C++ here. And then MPT project. Again, you can select other ones, but we are going with the MPT one. Name of the project, let's say transportation problem. And this is our first version because we are going to develop other versions. And directory, the folder that we are going to have the file in. So here, let's create a folder. Let's say C++ Cplex examples. And open it, select folder, and create. Okay, so it is an MPT Visual Studio C++ project for now. Let's add a Cpp file. Okay, so there are two ways to add Cpp file. One way is to go to the project name. This is called the project name, and right-click on it and go to the Add New Item. Again, the project name, Add New Item. Here we are going to have a Cpp file, a C++ file, and then we select this one. We name it as main. This is main is a usual name for our main Cpp file, and then add. So as you can see here, we have a Cpp file appeared here. So let's add some libraries or functions or built-in headers if you are talking in the C++ jargon. Let's start with include, and then the first one we want to add is IO stream, right? Because we want to use cout and cin and many other functions that are existing in this function, in this library. And then we are going to use std, using namespace std. These are very common practice for every C++ application, regardless of the Cplex or anything. And then we are going to have a main function because C++ only compiles and operates the main function. So now that we have the main function, let's have the problem parameters defined, right? I mean, we have this problem here. We have suppliers and demand and C. These are our parameters. Let's say we have, for now, number of suppliers is 6. Okay, and number of demand points are, let's say, 5. Or let's say 5 is maybe time consuming, let's say 4 and 3, right? And then we are going to have array for the suppliers, right? Array, we are defining a pointer array. I mean, there are other ways to define an array. Array means 1 by n matrix. Okay, this is called array. Let's name it S. S. New int. It should be number of suppliers, and then we can define it like, let's say we have 10, 30, 40, and 20. These are parameters of the problem. And then similarly, we should have something for demand parameters, how much customers are demanding, right? And then inside the curly braces, we are going to have, let's say, 20, 50, and 30. How about our cost parameter? Cost parameter, if you look at here, it is a 2-dimensional parameter. It's a matrix, basically. It is not an array anymore. So for that, we are going to have 2 of these asterisks, meaning that it is a 2-dimensional pointer array. Again, there are other ways to define, and I will talk about it briefly, but this is the most straightforward way to define multi-dimensional arrays. Let's say C equals new int number of rows, let's say n of s, and then each of these should be a pointer arrays. Then I have the numbers for each of them here. Let's copy and paste from this file. Okay, so this is our C values. This is our matrix. So if you send any shipment from supplier 1 to demand point 1, it will cost us 2, a unit of shipment, and so on and so forth. So now that we defined everything, the required parameters for the problem, we can wrap everything inside a region. This is a very good functionality in Visual Basic. And let's say problem data. Let's name it problem data, right? And let's have everything inside this. So see what happens now? We can collapse the code here and have a more organized problem. Let's start with some other the main reason for this tutorial, adding the Cplex functions and Cpls capabilities. I'm going back to this presentation. So for setting up the Cplex for C++ in Visual Studio, it is not very straightforward. Setting up Cplex for Python and MATLAB and C# are very straightforward. They are easy. However, it is not the case for C++. And I have all the steps required in this presentation. So make sure that ilog is installed. We made sure. Make sure the compiler is using the 64-bit platform. It is not. We are changing it to 64, right? And then go to C, C++ general additional include. We are going to this directory now. It is here. Again, the name of the project, right-click, go to the properties. Here you see that a lot of things happens. What we are going to deal with is C and C++ for now. General, again, it says go to the general one, and then copy and paste these two directories. This is additional include directories, add. You can either go to find the required folder, or we can simply have this, let me say, this directory is copy and paste here. Okay, this is one way. This is this one. And creating another line and having the next directory. Okay, instead of this, you could click on these three dots and go to the location that your Cplex is installed. Usually it is in the program file, not the other one. This one 64 bits and IBM, ilog, and here you can consert and include and select the folder. Notice the red fonts here for this number. This number can change for your machine. It is the version of the Cplex. In my machine, it is 129. The version is 129. In yours, it may be 128 or lower or more than this. So OK, and then apply. We haven't done yet. I told you it is not very straightforward. So the next step is to go into the same window, this time for processor and processor definitions. We are in the same window, this preprocessor definition, edit, and instead of these words, we are going to copy and paste some other keywords. These are basically compiler keywords. And so there are two keywords that we could add. This one is the first one, or we could add this one. I added this second batch of code. And apply. Again, we haven't done yet. The next one is to go into the multi-threaded DLL and changing the parameter. This one, code generation, runtime library, multi-threaded debug. Instead of this, we have to choose this one, multi-threaded DLL. Okay. Now we have completed the C, C++ section. We have another one to do for the linker section. And that is, again, linker input, copy and paste these three lines. Again, these red fonts can change in your machine, depending on the Visual Studio that you are using or the Cplex that you are using. Okay, let's add these three lines and hopefully get ready to recall the Cplex. Input, edit, and I'm copy and pasting these three lines. These are the three lines here. Okay, and apply. And okay, now we are ready to recall the Cplex function. Again, include. So IL Cplex, the other one, this lower one, and ILO Cplex, this one. We added and it didn't throw error. If it shows you some red lines here or red flags, you haven't done the setup step properly. Okay, now we can use Cplex solver actually. So before going to the solver, let's introduce a few main essential Cplex commands. In this tutorial, my focus is to give the bare minimum to start coding. Obviously, Cplex does have many other commands, but this tutorial's goal is to give the bare minimum to be able to start coding and coding efficiently. So ILO environment, this is defines everything that can happen to our problem. So for example one, this is our environment. Environment can have models, which is this one. Environment can have solution, which we are going to create. And environment can have tools and everything that can be related to this model. This is the environment. And then we can have model. Model actually is the set of constraints and object function. This is the model, regardless of the solution. And then we have ILO Cplex. ILO Cplex is responsible for solving and basically post-processing, like getting the values of the object function value or the value for the decision variables. And we are going to see examples. So the first thing we are going to do in every C++ Cplex coding is to create an environment, like IRO env. Many commands in C++ Cplex starts with ILO. It's a shortening for ilog. Okay, this is, we call our environment env, and then we are going to have a model, ILO model, because we have constraints and object function. Inside this environment, I declare this model inside this environment. And then we are now ready to define our decision variables. So Cplex and C++ allows us to define only one-dimensional decision variables. And this is the syntax for one-dimensional decision variable. ILO, num, var, array. ILOC, numerical variable, and this is an array, not a matrix, okay? So we can have, for example, however, look at the problem here. Our decision variable is not an array, it is a matrix, right? I mean, it is a two-dimensional array, it is not an array. So how can we define a two-dimensional decision variable in Cplex and C++? The way we do that is to define a new data structure. I commented this line and came before the main function, and I'm going to define a new data structure. And the word for that is type diff. We are defining a new type of data structure. And for that, we are going to have ILO array, like this one, ILO array, ILO num var array, this one, and we are going to name our new data structure as num-var two-dimensional, let's say. It is arbitrary name. You could name it anything else, like variable 2D. You could avoid this numerical interface. Okay, this is enables us to define two-dimensional decision variables. How about three-dimensional? Like in many problems, we have three-dimensional arrays. The same way, ILO array, but instead of ILO and var array, we want to copy a collection of two-dimensional arrays. And I'm naming it num-var 3D, right? This one enables us to define a two-dimensional decision variable. The other one for three-dimensional. Okay, now let's go back to the x variable. Let's define x as a two-dimensional array, num-var 2D, right? We just defined it. This is an x. This x variable is inside the environment, right? And how many rows it does have? It does have an s rows. Okay, the number of rows in this two-dimensional array is in our supplier. And for, let's say, traverse every of these rows and make sure that we populate these rows with decision variables. Now we can say x of s equals ILO num var array. Notice that each of these rows are array. Each of these rows are array. And again, it is inside environment. How many columns do we have in each row? Number of demand points. What is the lower bound for this variable? It starts from 0 because look at here. I mean, this is the type we have, 0, 1 up to infinity. And what is the upper bound? ILO infinity. And what is the type of the variable? ILO integer. Okay, ILO integer. If it is a continuous variable, we could use ILO float, like this one. But now, let's say it is integer. And that's it. We define our decision variable. Again, we can wrap everything inside a region, define decision variables, right? So look at what we have done so far. We created the problem data, and we also defined our decision variable or variables if you had many. So the next step is to define the object function or add the constraint. Let's say we are defining the object function now. For that, let's go back to the example. This is our object function. It has a two double summation sum notation here. We have to traverse both suppliers and demand points. However, Cplex doesn't offer a two-dimensional sum command. There is no two-dimensional summation in the Cplex C++. What we are going, it does have one-dimensional sum, but it is a little bit clunky and is difficult to work with. What I use usually is to define an ILO, let's go back here, ILO expression. Expression is a collection of terms, and each of these terms can be a variable or a number, anything. Okay, so let's go talk about ILO expression for the object function. So we are going to define an expression. This expression is going to be a collection of variables, a collection of terms, let's say. Again, it is inside the environment that we defined. We have two-dimensional double summation, pardon me. And the first one traverses the supply point, the second one traverses the demand point, right, this one. And we are going to have, we are adding each of these terms. So here, each of these terms include an X variable and as well as this parameter, C parameter here. So it is C SD multiplied by X SD, right? So this is collection of, actually we defined these two double summation, but we haven't added the summation to our model. So the way we do that is that model.add, and since we are adding the objective function, we have to use ILO minimize. Again, this is inside this environment, and we are going to minimize this collection of C and X's. Okay, we added this objective function because it's a minimization problem. We used ILO minimize. It was maximization. We had used ILO maximize, and that's it. We defined our object function. Let's go to the constraints, right? Also, we can have object function region and put everything here and organize the code. Okay, again, for the constraints, first of all, we have to add some constraint for every supplier and for every demand. Let's say we are dealing with this first one. For every supplier, we add some X's such that they are less than or equal to the supply point. Again, we have a summation for which we can use ILO expression. So let's say we are traversing every supply point. This 4 is for this part. And for every S, we are going to have ILO expression, ILO XPR. And let's say this time we'll name it X1. And then this one is going to traverse demand points, right? So EXP1 plus equal is XD. And that's it. We are now ready to add everything to our model. Model add, look at the expression here, this constraint. XP1 is less than or equal to the S of S. And let's do that. XP1 is less than or equal to S of S. And that's it. We added the first set of constraints. Notice that this constraint is added for every supply point. Okay, how about the next one? You can also add some comments to clarify your code, like this one. It is not very important to clarify for small codes like this, but when it grows, it is essential. So we are going to traverse the demand point in the next constraint. Again, a for loop for that. And again, ILO expression, let's say exp2 for this environment. And we are going to have a summation, but this time for supply points. Okay, and for each of them, we are going to add this constraint, exp2 is greater than equal to the demand. Okay, so for now, we basically defined our model because we added the constraints like this, and we also added the object function. What remains is to solve this problem actually, and we are going to do that next with the command of ILO Cplex. So now we are creating a Cplex object, naming it Cplex, and we are feeding this model to the Cplex because we are going to solve the model that we defined. And let's say Cplex, everything is ready to be solved. So that's it. We created our model and solved it. And let's see if it throws any error. For that, we are going to have build solution or rebuild solution. Better option is to use the rebuild solution. It compiled successfully, but let's see if it gives us any reasonable numbers. Okay, it ran, but we are not sure if what is the object function, what is the value of the decision variables. It actually shows us some, the writings and which we don't care much. For example, it says the Cplex reduced some rows and simplified. We don't care much about those explanations. We care about the object function and the value of the decision variables. So to remove that log file, we can have, before solving the Cplex, set out this environment and get null stream. Okay, it basically turns off the logging file. You see, nothing is shown here. The process of solving and explanations are not visible anymore. So, but in many cases, we are not basically able to solve the problem in the first run. It will throw error. It may be infeasible or unbounded or any other problem. So the safer way for this line is to replace it with this one here. It says that if it is not successful, if the solution is not optimal for any reason, timeout, the running out of the memory, anything, it throws an error notifying us there is something wrong with the code. If otherwise, this line, only it solves and gets the optimal solution and shows the required data. So let's say we want to get the object function now. It is solved, and we want to know what's the object function. For that, we are defining a double variable. Let's say obj, obj is a common name for object function, and Cplex get obj value, right? This one here. And then we want to basically deploy everything to the console window. Let's say this one might have the objective value is something, that we are going to shape. Objective Okay, let's run it. Now the object function value is 220. So how about the value for the x variables, right? For that, we need to traverse every single element in the x variable. It is two-dimensional, so we have to have two nested fors. And then let's say double x val equals Cplex. The code we use to get a value from the decision variable is to get value, this one, and then x of st. That's it. We can then show everything in the console window. Let's say this one doesn't match with the name that we defined. Okay, so you see the decision variable, the value of the decision variables appeared here. And we used get value method or function of the Cplex to get the values. However, you notice that some of them are -0, and that is because even though we define them integer variables, they are not stored as exactly as integer variables in the memory. They are stored a very negligible small number. Some of them are negative sign, some have positive sign, like this one. This is not actually stored as 0. It is something closer to 0. And that is the reason. We can, for example, have an if statement here saying that x val is greater than 0. We wanted to show. Otherwise, we are not interested. Like this one. And let's say, okay, we created the model, we solved it, but it is far from optimal. We as a graduate student, we need many things out of a C++ and Cplex. One of the things is the time that's required for running this whole code, right? So for that, we need to include another library called Chrono. Okay, and before everything starts, we are defining a start point, and we say Chrono high resolution clock, and then let's say now. Okay, it's started to keep track of the time until we tell it otherwise. So here, let's say we want to capture the time required to solve the solution. Again, auto, let's say end this time. And Chrono high resolution, again now. What remains is to capture the difference between end and start, right? I mean, for that, we use this notation. Elapsed time is chrono duration cast. It simply casts the end minus the difference between end and my start times. And then we need to deploy everything to the console window. Elapsed time is this elapsed variable, and count in terms of milliseconds. Let's say it is millisecond. The default is millisecond. Okay, elapsed time is 19 milliseconds. It is very short amount of time. Okay, any questions so far? Because we are going to have another version. So, anybody question?
I've got a few questions.
Mm-hmm.
How much faster is Cplex than Gurobi for these kind of problems? I know, like you mentioned that since it's a different type of language, but how does that translate in your experience?
I haven't used Gurobi in C++, but I have used it in MATLAB and I guess Python. I read a good article about that paper recently, and the conclusion was that it depends on the problem. Generally, they both of them perform well. I mean, for if you run them for many different problems, from network problems to mixed integer to stochastic problem to anything. Generally, they perform almost the same, but depending on specific problems, their performance differ.
Thanks. I have another question here as well. So how does you showed that the setup for this is pretty complicated. How does I'm just curious, like, how is it? Are you able to set this up on like a computing cluster and run larger scale problems?
That is a very good question. We are coming to that in the latest version of this code.
Okay.
If you don't have, yeah, we will talk about that.
Okay.
Okay.
Thank you.
So now you see that this setup is far from ideal. We entered every value for number of suppliers and demand, 4 and 3. What if we want to change it to, let's say, 14? Not many, not 400, but 14, let's say. Then we have to define everything and enter every number by hand and make sure that they are matching. For that, we are going to see our next version. Let's say, and this is where we stored. Copy and paste. Okay, and I'm running this VCX proj. Okay, so let's assume that instead of entering the variables, we want them to be generated randomly. This is what happens in many papers in grad school, right? I mean, we generate data and apply our algorithm and prove that the algorithm works better than the others and publish papers. Let's say we want to do a similar thing. We want to generate random data. For that, we need a random number generator. So we include this random header file to the Cplex, and then we can define, there are many different ways to define a random generator. One way is to define a class of random generators, like, let's say, rand library, right? This is a library. So class is nothing scary. Class is a collection of fields and functions or methods if you are talking the object-oriented jargon. A collection of methods and fields, and that is all the class is about. So I have the rand lib class implemented before. Let's say I'm going to explain it now. So these are the function fields that are available outside of the class. This public keyword indicates that they are available outside of the class, and we will see how. It does have 3 methods because the first one, we want to generate continuous uniform distribution between 0 and 1. For the next one, random int, rand int, we want to generate discrete uniform distribution between A and B. And for the last one, continuous uniform distribution between A and B. You can add your own methods. You can define many other methods like normal distribution, gamma, any other thing. And this one here is called constructor because it has the same name as the class itself, randlib and randlib. It takes a value, integer value, and it assigns it to the seed, okay? And also it assigns it to the random generator machine, random generator engine. So here is the thing. Many things is complicated in C++, as we saw in the Cplex setup. The other thing that's complicated is the use of random generators. It is not very straightforward to define a random generator engine in C++. This is how we define an engine, this one, std default random engine, and then we use this engine to generate different types of random numbers. So let's implement these methods, right? We declare them inside the class. We simply declare them, but there is nothing implemented yet. For that, I have the implementations here to save some time because we are going to cover a lot if time permits. So this returns a double number. It is inside this class. This is the class, and double colons indicates that this is a method of this class. Okay, and this is how we generate uniform real distribution, and it returns double. This is the syntax between 0 and 1, and we simply return this value. You see that it's not very straightforward. It is, I have implemented in C# and MATLAB, Python. They are much more easier than this. And this is about rand, also about random integer, like this one. Another way to generate random integer is to use directly the Cplex function, the C++ function, uniform int distribution. But I found this method much more reliable than the built-in function. And also uniform random distribution, A and B, we simply return this value. Okay, so now let's say instead of 5, we have 10. Instead of 3, we have 9 of them. Now we can simply get rid of these values as well as here. But then we have to populate these variables. They are now empty. We declared them, but they are not. They have not been populated yet. So for that, let's say we are going to populate the demand for now. For int demand and d of d, let's say. Okay, before populating anything, we have to create an instance of this class. We define the class, okay, but we cannot use it without instantiating it. It is called instantiating. It is making an object of this class. If it was an static class that we are going to see in a few minutes, then it should have static keyword in each of its methods and fields, but it is not the case for this one. So we have to create an object. Okay, this is a main function. Before doing anything inside this problem data, we create an object of this rand lib. And let's say our seed is, how many people are we in this talk? 24. Let's say seed is 24. Okay, so this seed helps us to generate the same numbers whenever we run the same problem. That is all about the seed. So RL, notice that the name of this object is RL. And dot, because it's not class, it's an object, we didn't use double colons, we use dot. And let's say random integer, we are going to have a random integer number. And between 20 and 150, for example, any number, right? And then for the supply, we can do the same. RL rand int, and let's say this is 150, 190. However, for this problem, this transportation problem, it is better than the sum of supplies is greater. I mean, it should be greater than the sum of demands, obviously, but it is better than they are close to each other. They are not far from each other, not like that. I mean, we don't want a supply, the total supplies is 1,000, but the total demand is 5, for example. It is not a very interesting problem. We want them to be kind of equal to each other. So for that, I implemented this code in here, which makes sure that we generate supply points and demand points that are closer to each other in summation. Okay, I have to define this one. Okay, we start everything in dsum and ssum, and then we somehow adjusted the supply values so that the summation of supplies are kind of equal to the summation of demand. That is what happens in these three couple of lines. You can also we can see the numbers that we generated. Like this demand point 0, 58, and so on and so forth until the end. If you run it again, it will generate the same numbers because we gave it a seed. Okay, so let's generate our other parameters, which is C matrix, right? Again, C matrix is, let's say, something between 1 and 15, again, a random integer. It could be anything else, normal distribution, anything. And the rest is the same as before, right? I mean, we have the object function as the same as before, constraints and solution and everything as before. So let's run it. Okay, it printed out the demand point values and the decision variable values, the time elapsed, and the objective function, the object value of the solution. And we can now easily see that we can increase these numbers, the supplier point and demand points. Okay, it is too much, so we may want to consider turning off commenting out this section to not print out the values of the X, and also this one. Okay, it's solved under a second because it is a very easy problem. And this is our object function value. So any questions so far? If there is no question, we can go to the next version of the problem where we are going to use
the double colon.
Say it again.
Can you say about the double colon you used once after the rand library, line number 39?
39, this one, right?
Yeah.
This generates us a uniform, let's say the definition here, continuous uniform distribution between A and B. Okay. The definition is that this gives us a random number between 0 and 1, right? Look at the definition. Rand. It gives us a random number between 0 and 1. And this is how we generate a random number between A and B. Okay. So suppose that your A is 10 and B is 50, right? And suppose that your output of rand is 0.4. Then your number would be 10 plus
Okay, I get it.
this, right? That's the way we generate a random number between 10 and 50.
And rand library, Leibniz rand library, right? RANDLIB, it's the library, right? Rand library, right?
Yes, this one, right?
Yeah.
Randlib is a random. I mean, you can name it differently. It is arbitrary.
Okay.
So for that, let's define our third version of the code. What if we want more organization and a better efficient coding C++. Okay, so this is what we had before. We have a random class, and then we define the methods, and we have these numbers here, we try different numbers. But let's say this is messy. What if, for example, instead of 3 methods, we have 5 or 10 methods? Then we have to define them all here, and all of a sudden we are in line, for example, 300 and we haven't defined the main function yet. And the organization of these kind of codes are very difficult. For that, we are going to define a header file. Okay, header file allows us to share codes between different C++ scripts file. If you have, instead of, we only have one CPP file here. Suppose that our problem is such that we have multiple of CPP files. We have master problem, we have sub problems, and so on and so forth. How can we share different classes, different variables among them? This header file is for sharing codes between different CPP files. Let's say we name it rand generator, right? And all we need for random generator is to include the random file, random header file. And then this is our declaration of the class. We declare the class here, but we don't usually implement the class inside the header file. This is a header.h. We don't implement unless, I mean, we could technically implement, but it creates some complications. So let's say we have another CPP file to implement whatever we had inside this header file. Okay, this is our header file. We are going to implement these methods. So include this header file because otherwise it will throw an error. And then we simply implemented everything here. Now it is more organized. If we had normal distribution or gamma distribution, we can declare them here and simply implement everything in the other file. Okay, so here, for example, we can get rid of all these lines and only add include this rand gen. So compiler, whenever it sees this line, goes to this function, goes to this file here and copy and paste everything here. This is what compiler does. So let's rebuild it. Okay, it is successful. If you run it, it will run. Okay, but it is, this time it is more organized. How about doing the same for this random generation? What if instead of 3 parameters, we have 15 parameters? It is very commonplace for grad students to have many, many parameters in their problem. So for that, let's say we create another header file. Let's call it Cp data, transportation problem data. And let's have a class. Okay, it is called problem data class. It does have static members, these keywords here, indicating that we don't have to instantiate this class to be able to use these fields. And we will see why it is important and makes it more efficient. So it didn't recognize this rand lib simply because we didn't have this include rand generation header file here, right? So, and then we have populate parameters. Okay, populate parameters, instead of generating everything in the main file, we can generate everything outside of the main file and simply recall them here, fetch the data here. And for that, let's define another CPP file. Let's say problem data. And in this problem data, we have everything that we need. Okay. It throws an error because we haven't related it to its proper header file. We declared everything here in this, we declared this class inside TP data, but we don't have TP data as a header file here. So that is why it throws an error. Okay. So see what happens for the populate parameters. It gets a random generator. This is a object of type, this class randlib, okay? And then it populates demand parameter, this supply parameter, and then this C parameter here. Okay, now that we defined our functions and our header files, we can simply say problem data. Okay, we haven't imported the other one here. Cp, right? Problem data number of suppliers is 50, number of demand points is 60, right? And then we can simply say our data number of ns is problem data ns, and the other one is problem data nd. You can also give the seed to problem data. This is our seed. Okay, and then to populate the data, we need to create a randlib instance, right? Randlib instance with this seed here. And then simply we need to populate every data that we defined. Problem data, you see that we didn't create any object from problem data because everything here is defined as a static member. Okay, you can compare it with this one, for example. We don't have a static keyword, so we have to create an object to be able to use it. Here we don't have. Populate data, so everything is not populated. We don't need any of these. Like this one is not, I mean, we don't need to populate anything inside main function. We simply need to recall everything from the problem data. And for this one, again, problem data, double colon, C. So see how organized it becomes now. Okay, then this is not problem data. Let's say it is fetch data. And this is, let's name it problem setting. Right? Problem setting, we set the problem parameters here. These are the essential parameters for our problem. These are the parameters that define everything, 50 and 60. And then fetch data here. And again, we know the rest is the same. The object function, the constraint, everything is the same as before. Okay, build. RL redefinition, let's say, when did we define this? Okay. Let's run it. Okay. Again, we can simply increase the numbers very easily. It will obviously take a little bit more time, but it is an easy problem. So yeah, 5 seconds. I mean, this is in terms of milliseconds, so it is 5.6 seconds. And this is the object function. Okay, any questions so far before we go to the next one? So we have a problem. Still, it is not ideal because we are grad students and we try many different instance sizes, right? I mean, 50, 60, and in the current version, we have to wait for the solution and write the numbers, right? Is there any way to write everything or write the solution into a file? That is what we are going to see in the next version. And this one, main, everything else is the same. However, after the problem is solved, we want to deploy the solution to a file. For that, we need to have another header file called fstream, file stream. Okay. So let's say on a text file, you want to write everything on a text file, let's say for now. In order to initiate a file, we have to start with of stream. Let's say it is the name of the handle is FID. We want to name it in a way to distinguish it from other problems. For example, if the problem size is 50 and 60, we want to incorporate this 50 and 60 somehow in the file name. Right? Okay, let's do that. Let's collapse everything that's here. For that, we can have string file name. And I have the implementation here. I can copy and paste to save some time. Okay, transportation problem. We casted this number of suppliers to a string, std to a string, a dash, and the number of demand points, and txt, because we want to save everything inside a text file. So the rest is similar to what we do to deploy for the console window. So for console, I mean, this window is called this black window. This one is called console window, this one. We use cout to write something in this window, right? The syntax is the same, but instead of cout, we have to write FID. Okay, FID, let's open the file name. And then FID, we can write anything we want, like I have here, we want to write what is the size of the problem, NS and ND. We want to write what is the CPU time, elapsed time, and what is the object function. Once we're done with our writings, we could also write the value of decision variables. It is up to us. We're not going to do that here, but it is easy, the same way that we did for the console. So once we did that, fid.close, we close the file to save everything. Now let's see what happens. Problem setting, this is 50, 60. Let's run it. Okay, let's go here. You see it here, we have an output named appropriately 50 and 60. And if we open it, okay, this is what we have inside the file. Problem size, number of suppliers, demand 50, 60. CPU time, because it is in terms of seconds. I mean, we divided it by 100 and it rounded down. And the object value is this one. And if you run another problem, let's say this one, it will create another file. Look at here, 150, 160, right? However, most of the time we run hundreds of instances, and we don't want to have like hundreds of these instances lined up in a single folder. Is there any way to write everything inside one file? Turns out there is. So let's comment out this section. The way we do that to write it on a single file is this one in here. Yes. Again, the same as before, but this time the name of the file is TP result because we are going to store everything inside this file. And this is the keyword to store everything inside the file. Whenever it finds this file, goes to the last line of the page and writes down these numbers. If this file doesn't exist, it creates one. Okay. So, and we wrote some information inside this file and closed it. And let's see what happens now. Okay, we have this one here. If I could. Okay, this one. And then let's say we change these numbers, 10 and let's say 12 and 10, and run it again. Let's say another one, 14 or 17, and run it again. See what happened to this file. Okay, it wrote everything after each other in the single file. This is the first one that we ran, the second one, and the third one. The beauty of this file is that we can copy and paste every result to Excel file and analyze everything that we have, right? I mean, copy and paste here. And you notice that this is number of suppliers, demand, and this is the seed. These are the essential information for our problem. Any questions so far before we go to the last version of this problem?
Yeah, so I have a question on that, on the data structure. So the text file you have created, instead of a text file, can I write everything to a CSV file?
Yes, you can. You can also write it to Excel file. I mean, we don't cover that part here, but I have written in Excel file several times in different codes.
Yeah, that's
Okay.
So just one more question. So what is the difference between the .cpp file and .h file? Because you have .cpp file randgen as the .cpp file as well as the .h file.
Yes.
So we are importing the .h file in the code, right?
Yeah,
So,
we defined this header file. This is a header .h, right?
okay.
This header file is to share different codes among different CPP files.
Okay.
I mean, in MATLAB, for example, you only need to have the same, let's say, scripts in the same folder. You don't have to recall them. You don't have to do anything. They are internally shared. Or in Python, you just have to use import such file, and that's it. In C++, you need to have a header file. And in header file, you cannot implement a class or method. I mean, technically you can with some complications, but normally you can't.
Okay.
To implement these, I mean, fields and methods and stuff, we need to create another CPP file, ranging.
Okay.
Okay. So coming back to Eric's question, how can we deploy everything to another machine? I mean, what if my friend has a better machine that runs faster than mine, and I want to implement everything in that one? Or we have here in NCS data, we have VCL, a very powerful machines that allows us to run different problems. So for that, we are going to see how we can run a problem from a command window first. Okay. So let me close this one and create our last version. Okay, this is what we have now. This one. Let's compile it one more time. It is compiled successfully. So let's go back to the exe file. So every C++ gives us an executable file like this. Okay. we compiled it in a debug mode, this one, which, I mean, debug mode allows us to have breakpoints and for debugging the code. But if you want it to become faster, you need to compile everything in the release mode. If you are sure that your code is correct and everything is fine, compile the last product of your code in the release mode. But for now, let's say we compile it in the debug mode. So if I simply double click on this executable file, it will run, and I mean, you see that it produced, I mean, a file and stored everything in that, right? That is what we have here, 17 and 10. We can also run it from command window, command prompt. But for that, we need to change the directory, cd. Change the directory, and the directory of this file is this one here. Copy and paste here. And then we want to execute tp0.exe. Right? This is what happens. I mean, elapsed time 10 and object value, this one. However, you see that we cannot control every parameter. We cannot define the number of suppliers, number of demands, anything. We cannot do that, right? So in order to be able to, okay, this is the file, to control our code outside of this Visual Studio and doesn't depend on this Visual Studio or anything, and only work with the executable file, we should add some more keywords to the main function, this main one here. Like, for example, these are the functions that usually we add, variables, argc and character pointer argv, okay? And then we say, if the command window, okay, if argc, meaning that the number of arguments in the command window. This is the number of arguments here. Currently, we only have one argument in the command window, and the number of arguments is 1. We want something like this. We ideally want, for example, our supply become 40, our demand point 50, and our seed, let's say 85. This is our ideal. We can control everything outside of the Visual Studio. We cannot currently, but we are going to implement. This is argc. We are telling if it is greater than or equal to 2, it means that we have more than one argument, and we have to take care of that. So this is what we do for that. Problem data, number of supplier. This is a simple conversion to integer number, argv of 1, like this argv. It means that not the first argument, but the second argument. Notice that it starts, the indexing starts from 0. Okay, so it says that whatever is the second number, whatever it is, convert it to integer number and put it inside this ns, number of supplier. And for the number of demand, the second one, consider it as a number of demand point, and the third one as the seed. Otherwise, if you don't give it enough arguments, it will simply, for example, let's say our default values should be this one, right? If we, instead of this version, we run it like this one, we tell problem that then if we don't have enough arguments, simply use this default values, right? That is what happens. Let's say then run it. It will run with the default value, obviously. If you run it from inside the Visual Studio, it will run from the default value. Okay, let's go back here, 50 and 69. Okay, and then you see that the object, the function value changes, this elapsed time changes, and if we check the TP result, you can see that this one, 45, 89, the seed, and this is object function, and this is the elapsed time in terms of second. If you run quite a large problem like this one, let's say then something more than 0 will happen for the elapsed time. Update this one. Okay. So I hope this answers your question, Eric. You can now deploy this executable file to any machine that you want. Okay. Here is another thing. What if currently you see that what happened in the command window? We open command window, we change the directory, cd change, but then we have to give each of these problems one by one, right? Like 50, 40, 69. And then the next problem, we have to update the numbers. Is there any way to automate this process? Again, the answer is yes. And this is called the batch file running. For that, we need to create a text file first. Let's say problems to run. Let's open it. And let's get rid of this one for a while. And let's say we have different numbers, different instances to run. Okay, I have some of them here. So this is the change of the folder that happens. We change the folder to the where we store the executable file. And then we have these values for, I mean, we try, let's say, trying different values for number of suppliers and number of demands. And also this is our seed, different seeds. Okay, this is what happens normally in the grad school. We run hundreds of instances. Okay, so, and let's say if I have a little bit large instances. Yes, let's say we also have some of these instances. Yes. Okay, store. Okay, we are now here. So this is something special for window. We change the name of this text file to bat, meaning to a batch file. Okay, this is a batch file. When we run, double click on this, it will open this command window and does whatever here in the command window. Whatever here will be done in the command window. So let's see. So I am closing the command window, double click. Okay. You see that it ran these many instances automatically. You can have hundreds of them, and you can just click on this batch file and come back 1 week later. And this is our results. Okay, every instance is run and with different number of suppliers and demands. This is object function, and this is our elapsed time. Then you can simply copy and paste everything to Excel file and analyze. Okay, any questions so far?
This presentation, this video, as well as the code will be uploaded and you will be given the link very soon. And if you have any further questions, you are always welcome to give your feedback. And we are available at, I'm just typing our email ID. We are available at this email ID. You are always welcome to give your feedback.
And again, thank you everybody for listening and participating.
Raman, great session.
Thanks, Raman. Thanks for
really
your session. Thanks for your time. We learned fundamentals of at least how to implement an optimization problem. And there are so many versions you develop from the base case to the advanced case. We really appreciate that. Thanks once again, and we will meet in the next meeting.
Yeah, sure. Thank you, everybody.
Thank you very much. It was really a very good session.
Thank you so much.